Now we keep going. We are building up a castle. Let's go for it. Now what we're looking at is chemical formulas, okay? Because we're going into interesting territory. I'm sure you're going to love it. Beautiful stuff. When we talk about chemical formulas, you remember, I mentioned and told you that saying simple compounds and complex compounds, that's not a good way of separating compounds. That's not a very important way. And we say that separating compounds into molecular and ionic is more important and it's better because it is related to their properties. Not only that, but again, it is what we will be using when we give compounds their formulas. When we give compounds their formulas, we are going back to what we just learned, which is what happens in an ionic compound and what happens in a molecular compound. So, now, when we are giving something a formula, right, we want to have a representative. We want to know what arrangement of atoms can we use to represent that compound. We're dealing with a compound, which is going to have more than one element, hydrogen and oxygen, blah, blah, blah. So we want to know, when we look at water and we say that water is H2O, what have we used to know that water is H2O and sodium chloride is NaCl? What have we used to know that? Okay, now there are two formulas which we'll use, which we'll have. One is they are chemical formulas. We call them chemical formulas, both of them. Okay, and they are the chemical formulas of ionic compounds and of covalent compounds. We start with the ones for covalent compounds. So the chemical formulas of a covalent compound is called the molecular formulas. Let me not say of a covalent compound. Let's say of a molecular compound. A molecular compound is a covalent, but we want to use the word molecular compound. So the chemical formula of a molecular compound is going to be called the molecular formula. So when you have something which has no metal in it, just non-metals like water, H2O, all these other guys, when we have a formula of them, we say we have a molecular formula. What is a molecular formula? What is a molecular formula? It is the formula of the molecule. And what do we do? What is it that we do? Well, what is a molecular formula? Let's first look at the definition and then we'll talk about it. It says that this is a formula that gives the exact numbers of each type of atom that is present in one molecule of the compound. We want to know the numbers of each atom that is going to be in one molecule. When we take one molecule, how many hydrogens do we have in there? How many oxygens do we have in there? We use that to then give that guy a formula. So, in other words, when you go to, I'm going to scroll up. When you go to water, we are back to water and see. This is very easy to give because water is very easy to give a formula. We are just going to look inside one molecule. Inside one molecule, and we will count. So molecular formula just comes from counting. We'll look inside one molecule and we'll count how many, what are the guys in there? Oh, there are hydrogens. How many? 2. So we'll say H2. And what else is there? Oxygen. Oh, how many? 1. So we'll say H2O. And we'll know this is going to be the molecular formula. It just tells us the numbers of all the atoms that are present in one molecule. Because remember, water is just made up of these same molecules. Another molecule here, another one here, another one here. Then they just have a small attraction. They attract one another, but it is not a chemical bond. It is not a chemical bond. It is just some attraction between them. So anyway, we have it like that, and we have these water molecules together. So what is important? I mean, you would say to me, why do we use only one molecule to represent our water? Because you see this molecule, it's a water. We can actually call this guy water. This is the water, this one molecule, because if you take it, it's going to have the boiling point of water. It's going to have everything about water is going to be there on this one molecule. So to us, this is water. This is the water. So we can just look at one molecule and we'll know. And we just count how many hydrogens are there, how many oxygens, then we will get the molecular formula. So molecular formula is so easy. Okay, it is the exact numbers of each type of atom. 2 hydrogens, 1 oxygen. That is our molecular formula. So easy. In one molecule, we just check in one molecule how many atoms are there of hydrogen, how many of them, we just bring them together. Now, why can we do that? It's because molecules are separate. They are discrete things. They exist as individual separate units. So we can take one molecule and treat it alone. We don't have to combine them together and try to count how many hydrogens they are together. No, we don't have to do that because each molecule stands alone. So we can take one molecule, look into it, then we'll know, oh, so each water molecule has 2 hydrogens and 1 oxygen. So when we say we are asking for the molecular formula, we are saying go inside one molecule and tell us how many of each atom you have. Tell us the types of atoms and how many atoms you have of that guy. So it will be 2 hydrogens, 1 oxygen. That's what you do. And here's the example. I've put example. Water, the molecular formula is H2O. Where did this formula come from? We just looked in one molecule. We just looked inside and we saw we have 2 hydrogens and 1 oxygen. That is where the formula came from. And it tells you that every water molecule has 2 hydrogen atoms and 1 oxygen atom. Another one is glucose. How do we know the formula for glucose to use when we are doing our chem? Well, just look inside. Look at what is inside. Oh, we have 6 carbon atoms. We have 12 hydrogen atoms. We have 6 oxygen atoms in one molecule. So it'll be one molecule of glucose. And that is, again, a molecular formula. Huh? You can see that water was actually a simple guy. And this glucose was a complex guy. But together now, in this new way of separating, we don't separate them as simple and complex. Together, they are one thing. They are molecular compounds. And we have given their molecular formulas right now. Just by looking inside the atom. Inside one molecule. We look inside one molecule. Okay? And we see what is inside. That will be the formula of that guy. Because if you can take one molecule of glucose, that's a glucose. It has all the properties of glucose, so that's a glucose. If you can see its structure, you now know the structure of glucose. Even if we now just combine them together, it's just a bunch of glucoses together. Okay? Now, what about this second one called the formula unit? This is another key word which you're going to meet. What is the formula unit? It is a chemical formula. It is a chemical formula, yes, but now it is no longer for a molecular compound. It is now for an ionic compound. Because you say, if you look at sodium chloride, look at it. What makes us say, have you ever wondered, what makes us say that this is NaCl? Why are we taking one Na and one Cl? What about all the others? Because we have this, let me circle in pink, we have this Na, we have another Na plus, we have another Na plus, we have another. Why are we taking only one and one Cl? And giving it, this is called a formula unit. This is a formula unit. It's not a molecular formula. It's a formula unit because we have a metal and a non-metal ionic bonding together. All right, now, what is a formula unit? What makes us say that NaCl is Na plus and Cl minus? Well, a formula unit shows you the smallest electrically neutral collection or combination of ions that is in your compound. So it's not going to look at all the ions. We know that they are together, they are in a pattern, but we'll see what combination can we have that leads to a neutral guy. Because what we want is to be electrically neutral. So we'll say, oh, if Na is just Na plus and Cl is just Cl minus, we can have a combination of one Na and one Cl. This will cancel and the charges will cancel and will remain with NaCl, which is electrically stable. And once we have it like that, then we're electrically neutral. Then we'll say, wow, that's it. So now we know the formula unit. It is based on the simplest ratio that leads to stability, to electroneutrality, okay? The smallest ratio of ions that can make an electrically neutral combination. Smallest ratio, so it could be, for sodium chloride, we said it is 1:1, NaCl. That is our formula unit. It shows you that we need 1 sodium and 1 chlorine, okay? We need 1 sodium and 1 chlorine to make that guy stable. And that will be what will represent the whole compound. We will only represent it by this guy, NaCl. Sometimes you may see it as, if it is magnesium chloride, it will be Mg, then Cl2. This is the smallest ratio, okay? And it's so easy because you just make the charges balanced. If things have different charges, let's say you have a B3 plus and an X2 minus, or or minus 2. What do you do when you want to make one compound? Or how do I get the formula unit for this guy, something that leads to stability? I'll just take 2 to B and 3 to X. So it becomes B2 X3, and this would be the end. This is the formula unit. You can't get another one. It's the formula unit. It's the simplest whole number ratio of ions. So you need 2B plus whatever, B3 plus ions, and 3 2X2 minus ions. You bring them together, you are going to get something that is electrically neutral. And that is what we'll be calling our formula unit. So formula unit just comes from you making the charges balance. If you can make the charges balance in an ionic compound, then you have the formula unit. Easy capeasy, lemon squeezy. That is how you do it. That's the difference between molecular formula and formula unit. For formula unit, it is about balancing. But for molecular formula, it's just about counting. You go into one molecule, you count, you are done. And that is the end. Bye.